All right, let's get into it. You know that feeling of a perfectly soft t-shirt or a great pair of jeans that are finally broken in? Well, that softness, it's not an accident. It's actually the result of this kind of hidden industrial journey, a big transformation from stiff and rigid to comfortable and wearable. So today, we're going to pull back the curtain on the very first and maybe most important step of that whole process.
I mean, really think about it. You go out, you buy a brand new cotton shirt, and it almost feels like you're wearing cardboard, right? It's not comfortable at all. Why would they do that? It seems completely backward for something that's supposed to be soft. Well, believe it or not, there's a very specific and super important reason for it.
And the culprit has a name: sizing. See, during the crazy high-speed, high-tension process of weaving fabric, those individual threads can snap really easily. So to stop that from happening, manufacturers coat all the threads in this starchy, glue-like gunk. It makes the thread super strong for weaving, but it leaves the final fabric stiff, unabsorbent, and pretty much useless as clothing.
So, here's the key. Before you can do anything else to that fabric, before you can dye it, print on it, or soften it, you have to get that starchy sizing off. And that process, the great undoing of the sizing, is called de-sizing. It is the absolute essential first step in what they call wet processing.
And you can see right here just how critical this one step is. Of course, you've got to remove the starch to make it soft, but think bigger. A fabric with sizing on it is like a sealed surface. Water, and more importantly, dye, just can't get in. De-sizing cracks that seal open, making the fabric super absorbent, which is what allows for those deep, vibrant colors. It literally preps the fabric for everything that comes next.
So, how did they used to solve this problem back in the day? Well, the first solutions were actually pretty clever in their simplicity. They relied on nature, a whole lot of time, and a little bit of brute force.
So the oldest method is called wrought steeping, and it is fascinatingly simple. You literally just soak the fabric in warm water. That is it. You see, water naturally has all these tiny organisms in it that produce enzymes. And if you give them enough time, we're talking 12 to 24 hours, these little helpers will slowly break down and basically turn that starch to mush. So, the upside? Hey, it's cheap and you don't need to add any special chemicals. The massive downside, though, it is incredibly slow, it takes up a huge amount of factory space, and here's the real kicker. If you leave it in for too long, those same little organisms that ate the starch will start to attack and damage the cotton fabric itself. It's a really risky game of patience. So naturally, manufacturers needed a faster, more reliable way to get this done. So they turned to chemistry. The next big evolution involved soaking the fabric in these powerful chemical solutions, either really strong acids or strong alkalis, to basically force the starch molecules to break down much, much faster. Let's just compare these two for a sec. Acid steeping, using stuff like sulfuric acid, is way faster. It cuts the time down to just 4 to 6 hours. But wow, is it risky. If your concentration is even a tiny bit off, you can seriously damage the cotton fibers. Alkali steeping is a little safer for the fabric, but it's slower, and it has its own problem. It can make the fabric shrink. So yeah, you get a faster solution, but one with some pretty serious trade-offs. This constant search, for a method that was fast, effective, and safe for the fabric eventually led to a much more sophisticated biological approach, one that uses nature's own tiny machines. And the answer was enzymes. An enzyme is basically a protein that acts as a biological catalyst. The absolute best way to think of it is like a microscopic, programmable pair of scissors. It's designed by nature to find one very specific thing and only that thing and cut it up, while completely ignoring everything else around it. And this is where the magic happens. Scientists found a specific type of enzyme called an amylase enzyme. Its one and only job is to seek out and break down starch. It doesn't see the cotton, it doesn't care about the cotton, it just goes after the starch. This solved the single biggest problem of the acid method. The risk of damaging the actual fabric was pretty much gone. And this diagram here, this shows the modern, almost elegant process that came out of that discovery. This is the enzymatic desizing method, and it's the gold standard in the industry today. It might look like a few steps, but each one is precisely controlled to get the perfect result every single time. So, how does it actually work? Well, first up, they prepare a bath with the enzymes, and they have to carefully control the temperature and the pH just to keep those tiny machines happy and active. Second, the fabric takes a quick dip, a process they call padding. Third, it's stored for just 3 to 4 hours, and in that time, the enzymes just go to town, breaking all the starch down into simple glucose. Finally, a simple wash rinses it all away. That's it. Quick, efficient, and totally safe.
Okay, but how do you know for sure that all that invisible starch is actually gone? You can't just feel it and guess, right? You need a fast, reliable test to check your work before you move on to the really expensive dyeing process.
And the industry uses this beautifully simple and effective quality control check, the iodine test. It's just a basic solution of a little potassium iodide and iodine in water. And one single drop of this stuff on the fabric tells you everything you need to know.
So if that drop turns a deep blue color, you've got a problem. That's the classic chemical reaction between iodine and starch. A blue result is a hard stop. It means the desizing process failed, and that fabric has to be treated all over again. Now, if the drop turns violet, you're on the right track. This color means the starch is partially broken down into smaller pieces. The enzymes are definitely working, but the job isn't quite finished yet. Almost there.
But if that drop turns brown, which is just the color of the iodine solution itself, that is the sign of success. It means there is zero starch left to react with. The fabric is completely desized, perfectly absorbent, and it's ready for the next stage.
So let's put it all together here. When you look at all the methods side by side, it becomes crystal clear why the industry evolved the way it did. It's all about finding that perfect balance of speed, cost, and most importantly, safety.
I mean, this table really tells the whole story, doesn't it? Just look at the time column. We go from a full 24 hours for rot steeping all the way down to just 3 to 4 hours for the enzymatic method. Then look at the risks. Shrinkage and degradation are huge problems in the older methods, but they are complete non-issues with the enzyme process. It's simply the fastest, safest, and most reliable tool for the job. No contest. You know, when you boil it all down, the entire journey of textile making is really just that. A series of problems and the incredibly clever solutions humans have come up with to solve them. The problem of thread breaking led to sizing, and then the problem of sizing led to this whole fascinating evolution of desizing.
And it is so important to remember that this isn't just some minor little step. Desizing is the very first chemical process a fabric goes through. Getting this one single step right is what makes everything else, every vibrant color, every soft finish, even possible. So the next time you pull on your favorite perfectly soft t-shirt, maybe you'll think about its hidden journey for a second, and about those invisible, microscopic machines that perform their one perfect task, all just to make it feel right against your skin.